Find the Henkel transform of f of x, which is equal to x power n if x lies between 0 and a, and 0 if x is greater than a and n is greater than minus 1, taking x jn of px as the kernel. So we know h of f of x, which is equal to integral 0 to infinite f of x into x into jn of p of x, jn of px dx, which is equal to, so we are going to split the integral. So integral is from 0 to infinite, right? So according to the given problem, so we are splitting into two integrals. So first is 0 to a, right, and a to infinite. So integral 0 to a x power n x into jn of px dx plus integral a to infinite 0 into x into jn px dx, because in given f of x is equal to x power n in the interval 0 to a, and 0 if x is greater than a, whatever the number a to infinite, it is 0, the value of f of x. So for the first integral, whenever we are splitting 0 to infinite, so first one 0 to a f of x into jn p of px dx. So in that case 0 to a we are putting x power n instead of f of x. In the second one a to infinite, we are putting f of x is equal to 0. So second integral becomes 0. So therefore h f of x, which is equal to 0 to a x power n into x, grouping that powers. So x power n plus 1 jn px dx. That is equation number 1. Now we know that the recurrence formula d by dx of x power n jn of x, which is equal to x power n jn minus 1 of x. So replacing n by n plus 1 in the formula and x by px, p into x on both sides. So we will get dx. So dx becomes because x is replaced by px, therefore dx, which is equal to p into dx, right? So replacing, so px power n plus 1 jn of px, which is equal to d by dx of px power n plus 1 jn plus 1 px, because first left hand side we are taking the left hand side, instead of x we are replacing px, right? So x power n becomes px power n replaced by n plus 1 power n plus 1, right? Then jn, because jn minus 1 become jn plus 1 minus 1, so plus 1 minus 1 get cancelled, you will get jn px. That is left hand side. First we are writing left hand side, then come to the right hand side. D by dx of, so dx become p into dx, so 1 by p into d by dx of, so replacing x by px, px power n is replaced by n plus 1, so px power n plus 1, so jn becomes jn plus 1, x become px, jn plus 1 px. So p power n plus 1 x power n plus 1 jn px, which is equal to d by p dx p power n plus 1 x power n plus 1 jn plus 1 px, right? We are grouping p and x power separately, right? So p power n plus 1 x power n plus 1 jn px, which is equal to, so p power n plus 1 is a constant, so taking outside the differentiation, so p power n plus 1 into 1 by p into d by dx x power n plus 1 jn plus 1 of px. So x power n plus 1 jn of px, which is equal to, because p power n plus 1 on the left hand side and p power n plus 1 on the right hand side of the inequality, sorry, equality, so both will get cancelled. So remaining you are having left hand side x power n plus 1 jn px, which is equal to 1 by p d by dx x power n plus 1 jn plus 1 of px. That is equation number 2. So from 1 and 2, comparing 1 and 2, so Hankel transform of f of x, which is equal to integral 0 to a 1 by p d by dx of x power n plus 1 j n plus 1 px dx. So that is equal to 1 by p is constant, so taking outside the integral, so 1 by p integral 0 to a d by dx of x power n plus 1 j n plus 1 of px into dx. So 1 by p integral 0 to a d derivative of it is a derivative of x power n plus 1 j n plus 1 of px. So that is 1 by p. So derivative of x, integral derivative of x, so x only. So here instead of x you are having x power n plus 1 j n plus 1 of px. So we will get x power n plus 1 j n plus 1 of px. So limit lower limit 0, upper limit a, because we know integral dx is equal to x. So 1 by p a power n plus 1 is applying the upper limit, a power n plus 1 j n plus 1 pa. Instead of x we are replacing the upper limit a, and similarly we are replacing the lower limit 0, so 0 into something 0, minus 0. So h of f of x, Hankel transformation of f of x, which is equal to a power n plus 1 by p j n plus 1 of pa. Right? Thanks. We'll see you in the next video.